She is the head department of pharmacology, yes, this one says, and also she's uh, consultant pediatrician, specialist in allergy, I believe, yeah. So thank you for agreeing to do the session. In fact, like we recently engaged with her and realized that she's doing a lot of different projects related to education using AI. So today we'll listen to her. The topic is titled Artificial Intelligence as a Tool for Excellence in Education. Dr. Seneviratne, over to you.
Thank you, Prof. Will. So, good morning to all of you. It's a great honor for us to be here in your special forum, actually. And thank you very much again for inviting us to share our experiences with you all. So, today I am with my team, Dr. Subul Manathunga from our Department of Pharmacology lecturer, and is especially interested in artificial intelligence and tool development. And also I have with me special invitee here, Dr. Lalani Velake from USA. She will be discussing on commercial bot development to share with you all her experiences as well. So to start with, so I'll be doing a kind of a presentation as an overview, and then we will go on with the next presenters. So artificial intelligence as a tool for excellence in education. So by now, I think all of us know what is artificial intelligence is. So no point in me going into those details, but to tell you something about why and how we use artificial intelligence these days. So it is mainly for knowledge shopping. So in earlier days, actually, if we want to seek something or if we want to find something on a specific subject or a fact, what we do is we just go on Wikipedia or any, yes, I don't know, another person is waiting. So we just go on and search Wikipedia, but so you will get some information. But if you want to get some specific content, specific information, like in medicine, if you want to ask something about related to medicine, then you should think where you should go. You should know something about where you can find some specific information. So you may have to go to UpToDate, or you have to go to Harvard University or something, CDC and NHS websites, and see all this information. So that comes like that. But in AI, but in certain other instances, like now, suppose you want to take a kind of a complex information, or information which related to complex scenario like this. Now this is a kind of a medical inclined question, actually. Now if you ask the students like this, 45-year-old male coming with admitted to the hospital with multiple injuries, and the patient has these parameters, and patient has these abnormal parameters as well. So excuse me for medical jargon here, but this patient is having these abnormal parameters as well. So how am I going to explain this type of thing? So in that case, if you go to Wikipedia or these type of accepted websites, you will not get that answer. But with AI, what the students will do is that they will just do ChatGPT, and they will find an answer. So that's the beauty of AI. So it will give you whatever the question, whatever the answer, which is whatever that will give you an answer for whatever the question which is posted. Now, so it is knowledge shopping in AI. So this is the answer actually given by the AI. So see the detailed answer. I don't want you all to read this thing, but it's a detailed answer, very comprehensive. But the thing is, this is actually speaking, this is actually wrong. So there are instances where the reliability comes as a question, right? So knowledge shopping is like vegetable shopping, actually. So if you all think for vegetable shopping. So the people in the audience, the ladies know how to select good vegetables when you shop. So in especially if you there are special techniques how to select good vegetables like in okra. So if you want to find out um, uh, non-mature ones, so crunchy okra, there's a special way to do that when you are shopping. So if you want the AI to do your knowledge shopping, it is like you're asking your servant to do the vegetable shopping. So the servant will come up with something, she will come up with something, but that might not suit you exactly. So there may be things which you do not like as well. So those are the things we have to think when we are asking the AI to do the knowledge shopping for us. Now, these are few of the things which I wanted to all of you to see. Now, this subject matters, biochemistry and physiology, are the initial kind of main subjects we teach in medicine when the students enter the medical faculty. So, so there are studies which has checked the ChatGPT performance in medical subjects. So how does ChatGPT will answer for particular questions in relation to medical subjects. Now here this study is on biochemistry and physiology. So they have posted several questions to ChatGPT and they have taken the answers back and examined the answers with the expert examiners. And what they have found is that most of the ChatGPT responses in physiology commended by the examiners as exemplary answers. But the ChatGPT performance is biochemistry questions is relatively lower, right? And when it comes to anatomy, again, anatomy is also one of the main subjects we teach in first years in medical school. So what does ChatGPT performance? So both ChatGPT and Bing has the ability to provide detailed, comprehensive descriptions of gross anatomy and human physiology. But the ability to provide proper information on anatomical variations was below average. So there are pros and cons. So it is not that 100% specific and well done. And so what is the thing we have to get out of it is that if you want to get use of AI, the things which we feed should be content specific. Content specific. So is human. So we know that humans make errors, and now the is AI as well. So AI is also can make AI also can make errors. So I think some people might know what this is: internal combustion engine. So we call it as piston engine as well, internal combustion engine or piston engine. Founded by Nicholas Otto 1876. So this is the kind of, so what does internal combustion engine does? So this is the kind of a framework. Out of that, what happened was that after the invention of this piston engine, the people invented cars, people invented airplanes, people invented trains, ships, grass cutters, helicopters. So so vast experience. So AI is also like a piston engine, and ChatGPT is just a car. So ChatGPT is just a car. So what actually we as academics should do is that what we feel is that we have to think about the ways and means of using AI and producing something out of it in order to suit our needs. So, so how to get the AI work for you? So, um, so we have specific tools with AI. So things are there in AI. So what we have to do is we have to just fix those things and see whether we can make something out of it which will suit our specific needs. Okay, so technology is pretty standard. Technology is pretty standard. So designing is the hard work. So we have to decide what we want. So designing part is the one which need to be done exactly. So how do we do that? So first we need to identify our problem. So do we need anything from AI? So first we need to identify our problem. So in our case, actually it was how to reduce failures in farmers. So we teach farm quality. So by the time I get the headship, there were many failures with this backlog and uh, increase in uh, reduction in duration of teaching schedules and increase in intake. So and also with the backlog, lot of accomplished failures. So I was thinking how we can help these students. So can AI help this event at this particular place? So that is what our question was. So we had a structured approach for this question. So one thing was that we need to identify who are at risk of failing, and then to devise a methodology to help and support learning and enhance exam performance. And then for those who still fail the exam, devise a methodology to let them not fail for a second time. Right? So those were the objectives for us. Right? So we have identified the problem, and then we thought whether we can apply AI tools to come out of this issue. Right? So, so here the HI comes before AI. What is HI is human intelligence. So you have to think on your own needs. Then only you can guide AI to suit your needs. So we had to develop AI tools to do the specific jobs you want. So to start with, what you need is you need to feed data and train a model. So the feeding data and training the model is the kind of one of the basic and one of the most important things. Now it's like parenting. Now you have to get the right unambiguous data. Now I'm a pediatrician, so I'm more inclined to pediatric things. So you get a child, so you have to guide the child nicely. You have to give the child unambiguous data. If you give unambiguous data, the child will kind of accomplish things quickly. So what do you mean by unambiguous data? Now for what is very kind of a simple example. Now this is, all of us know what this is. This is a table. Now so the children, when they start learning to speak, how do we guide them? We tell them, okay, so the mother comes and tell, okay, Buddha, this is mesa. And the father comes and tells, this is table. So what? Now two things comes to the child's mind. And we see children coming from well-educated professionals where there's a huge gap in speech delay. Why the delay? There's ambiguous data coming to the child. So they are developed, but everything goes like behind. So you have to be very specific about the data you feed to train your models. You have to use unambiguous data as much as possible. So you have to be an expert in the field as well. Now. Thing is that it's very crucial when you think about the data, the right type of data which you want to train the models. Now here in clinical fields, you have to be if you are going to develop something in clinical field, you have to be expert in clinical field, or else you have to join expert to your panel. So now here in clinical medicine, those are the people who know where to look and what information is correct, factually correct, before you enter that to your model. And also, when it comes as an output, whether it is correct or wrong, that has to be regularly scrutinized. For that, you had to be an expert on that. So those are the kind of things you have to think about it. And with regard to data, whether it is structured data or unstructured data, there are ways and means of feeding a tool when you are developing a tool. The ways and means of feeding the tool with data. But if you put too much unstructured data, the output will be um, not that task made, I think. So if you give more structured data, the thing will be much nicer. Now here at this moment, I just remember something when we were developing these tools to help our faculty students. So one of the tools which we wanted to develop is to give something, some kind of feedback for the students who fail exams, right? So then the question came, so how are you going to find data? So Kun asked me, so shall we insert or feed with a counseling book, right? So it will give counseling, kind of effective counseling for the student. So then actually I stepped back and I was thinking whether it will give a kind of a focused information for the student. So then I got the harder path or the more difficult part. And what we did was that by that time we had about 50 odd students who have failed the exams. So we were formulating counseling sessions for those students. So what we did was we did a structured feedback form to which they entered their own insights as to their weaknesses, their strengths, and what they actually want from as a guidance from the teachers. So like that, a structured sheet. And with that, they came to all of our lecturers in our department, and they had a individualized feedback. So think about 50 students coming as individual feedback. So huge time actually. And after that, what we did was we wrote detailed, personalized um, feedback for each student in each sheets, and that collected content specific personalized data was used to feed this model, and that was the success out of it. Right, so the right data, and it is when you are thinking about training a model, it is not always huge amount of data. Rather than the quantity, you have to think about the quality as well. So it has to be content specific quality data as well. Now, so the structured data, what is structured data, what is unstructured data, those things are written here, so I'm not going to read this slide completely. But once you have all this data, what you have to do is you have to clean and prepare the data. So you have to organize the data, you have to remove incomplete entries and classify it so as to make it stable for AI training. Gathering data for AI is not just collecting a large amount of information, as it says, but ensuring it's right type of data. It's about finding the right balance between quantity, quality, structure, and preparing it meticulously for AI training. So this part takes a hell of a lot of time actually, and it has to have a very good kind of a big thought process and time consuming, and as well as considerable amount of work as well. So how to organize your data effectively, these things will come up even if you type ChatGPT as well. So you have to choose descriptive file names, make it in different files, or provide context in your files, or where to find which thing. So label your data clearly. So if you want to rearrange it, if you want to put anything else again, then you know where to put those things as well. So, and also avoid redundant data. That is also very important. Not finding telling same thing on and on again. So be more summarized and focused when you think about providing data. So you think about your question, and you found your question, and you think about a model, and you think about your data, and you found your data, you prepared your data, you cleaned your data, and now you have and you decide your tool and you have done the tool. And once you have done the tool, that is the technical part, and that we will discuss later on. We will discuss with you all. And after you did that, what else you need to do? You have to test the AI tool as well. It's again just like a car. So once you did it, you have to see whether it is going on. So you have to test whether it is working. So that has to be done meticulously as well. Once everything done, here your new eyes is there for the deployment. So new tool is there. But after that also there's something else you need to do. You have to do post deployment checks and adjustment as well. In our tools which we developed, that also we did. Now initially when we put this feedback tool to practice, we got several comments. Now initially it was just like a sheet, so it was not conversational. Then the feedback came as it has to be conversational to be more naturalistic. So then we changed into a conversational mode. So like that. So there are feedbacks coming on. So you had to check what is going on, and you had to see whether there are nooks and cons coming on. So you had to readjust meticulously and adjust the things. So that is how it goes. So, so our small steps into AI tool development. So hereafter in next few slides, I'm going to tell you something about the things which we have developed. So the first one is the AI to predict student exam performance. So here, this was done with the use of machine learning. So we had a huge set of data, students, students' marks. We have several semesters in term quality. So we had student data on all these semesters. So with this data, we try to predict the students who are at risk of failing with the first semester marks. So that is what we did first with the use of machine learning, and that was quite successful, and we could get a tool out of with 100% sensitivity to predict a student who can fail out of the first exam marks. And then for the students who are at risk of failing, or for the students, then the next tool which was brought forward was this tool for automated assessment of SAQ questions. So why this is SAQ came beforehand or was more important than the other things? SAQ was the questions where the students were poorly performing. That was done, and that what we got from one of our previous studies as well. So SAQs were the questions the students were quite poorly performing, and so what this tool added, actually, so we know that our batches are quite large in medicine now. The student batches coming to around nearly 300, and our staff is not increasing. So we are having troubles with doing kind of personalized interventions for difficult students. Now, what is actually needed is actually personalized intervention for students if you just want to increase their SAQ performances. So, but it's not merely practical to correct 300 odd answers as formative exams or as a formative process before a main exam. Even great difficulty we mark in the exam answer scripts as well. So how can we help these students? So here comes the AI as a solution. So this AI tool was made to accomplish these needs. So what we did was we had a marking scheme, and once we did this tool, when we feed the marking scheme, and when the students feed their answers, they get a kind of a descriptive analysis of their answer with the marks. So what does the student say about it? We did it with few students, and these were the feedback given by students. I was surprised. I didn't think it would work out. So students knew that it is AI. So I hope it can make corrections work easier. so that students can send the answers and get corrected. It will help them to improve in the future. It is a good way to learn about how to write essay answers, because the AI tool gives individualized, step-by-step feedback. It gives the feedback in understandable and comprehensive way. Thank you very much. It is very helpful. Students might be able to send more answers more frequent in the future as AI marking is time saving. So that is what is needed by the students. More and more answer script. And then comes for the students who actually fail the exam out of all these ventures, the Sisu Apvela, that is AI companion, generative AI companion for giving feedback on how to improve exam performance. This was is the open AI application programming interface where students can type message and the responses as to how they can improve will appear in the interface. So this is something they can use it, and actually they have used it, and initially the initial rating was like this: how comfortable did you feel interacting with the program? So we asked these questions. Were the study techniques suggested by the AI useful to you? How satisfied were the AI feedback session? Did you find the advice on exam performance and stress management helpful? So everything got the rating about 4. And then we evaluated this method with expert mentors who had experience of more than 10 years of mentoring with students. So this is what they said: the feedback effectively addresses the key points of the students' strengths in their study performance and clearly identifies the students' weaknesses in their study performance, offers insightful suggestions for improvement, provides sufficient detail to guide the students. Feedback is personalized. It uses varied language, introduces novel perspective or ideas that enhance students' learning. So it was well accepted. So now we are going to deploy it thanks to the engineering faculty. So one of the difficulties we had after developing all these tools was actually we were doing it with our own laptops. So we had problem with that, and setting with the internet connections and how to give more access for the students whenever they wanted. So in that context, we requested from the faculty of Oshana again, and the team was kindly quite helpful for us, and ultimately we were able to build the site. So it is in near future we'll be able to send this to any student. Actually, this is not only for the pharmacology students. For any students who are failing exams, they can use this technology, use this tool, and see whether they can improve or they can get any advice, and they can improve on that. So to sum up the things, so what we discussed, we discussed about the importance of identifying the problem you want to solve with AI, the clean and preparation of data, choosing an AI technology, build and train model, test the model, deploy the model, and post-deployment survey. And here the Sukun will be discussing more on the technical aspect on developing the tool and what we did. So gratitude for everybody who supported this venture, and is
Very good morning to you. Thanks a lot for having us today. So the topic for me to discuss is actually about taming LLM. So how to manipulate the large language models to get the use that we need out of it. So before going into the technical details, I would like to just give some background information about how these large language models actually work. So it works like this. Just think, now you have some input. That input can be a sentence, a paragraph, an image. It can be anything. But this has to be gone through this large language model to produce some output. So that's basically what's happening. So it's very difficult for us to wrap up our mind around the concept of large language models. We cannot see it. So one way to visualize it is think of a black box. So in one side you have different slots that you can put your inputs into, and there will be some processing in this black box and something will be coming out of this model. So actually large language models are just computer programs. They are good at only one thing. They can do only one thing, that is simply predicting the next most probable word when you give a sequence of words. So that is the only thing that a large language model can do. But the problem is the computers do not actually understand words or images or anything. What they understand is the numbers. So what will happen is, first any input that you will be giving, for example, assume that you are giving a sentence to the computer. It will be splitting this sentence into words. Actually it's token, but for our conversation let's call it the words. So then for each words a number, a numeric value will be assigned. So that value will represent this word. Okay. So these values will be inserted into this black box model, and another value will be giving out of this one. So this model, this black box has numerous knobs. So just imagine there are millions of knobs in this black box where you can tune. So based on the setting of these knobs, the output that you will be getting will differ. So what is meant by large language model training is finding the optimal position of these knobs. So when you have tuned these knobs to the optimal status, then you will be getting a good answer from the other end. So that's how the large language models work. So for example, now imagine now you have given a sentence and it has been converted into a set of numbers like this. And this grid here represents the setting of the knobs. We call it weights or parameters when it comes to the large language models. And finally, the large language model will be calculating how probable the next word in that sequence is. So it will be going through all of its vocabulary and will be assigning a probability, and it will be selecting the most probable next word that should be coming after that sequence. And this will be repeated iteratively. So finally you will be getting word by word until a stop token or a message that says now, okay, now your generation is over. Until that message is generated, a sequence of words will be generated. So that's how the large language models work. There's nothing more, it's just predicting the next word or choosing the most probable next word after a sequence. So that's what is happening in the large language models. And I would like to clarify some misconceptions that general public might be having, that ChatGPT is not equal to a large language model. ChatGPT is just an application of a large language model. So what a large language model does is it just predicts the next word. ChatGPT is meant, or it is constructed in a way that it will be engaging with the user in a conversational manner. So whatever you input into that input box, that will under the hood undergo some pre-processing. So there will be some more information being added to what you will be inserting to make it more engaging. So but that part is hidden from us because that is meant for a conversational engine. So actually when we want to harness the full potential of a large language model, going for ChatGPT would not be the best option, because ChatGPT was made for a particular purpose, to be engaging, to maintain a conversation. But if we want to harness the true potential, we will have to access this actual core model. And actually the companies that are developing the large language models like Anthropic, OpenAI, they are providing ways for us to access this core model as well through their application programming interfaces, APIs. So that's the thing that we will be utilizing when we are developing AI tools, not the higher order things like ChatGPT, because our control on the large language model will be less if you use products like that. So we will just have a higher level overview of what happens when a large language model gets trained. So first, can you remember that black box analog that we discussed? So initially you don't know the parameter settings of this box. So what you do is you simply set it into a random setting. then you will be feeding lots and lots of data, and you will be examining the output that comes. If it suits, if it actually suits to the sequence that you input, then that's fine. But until then, you will be turning these knobs and tuning this. So once you tune this, we call the language model is trained. So what actually happens is, the original data that will be fed into the model, that will not be retained as is in the model. What will happen is, those data will be scattered and shattered around all the model weights. In other words, the training data that we will be supplying will be encoded in this model as weights, distributed across this large network of large neural network. So, for example, if we take ChatGPT, the model that is powering ChatGPT is GPT 3.5, which has more than 170 billion parameters. So, whatever you feed into that will be going through this 175 billion parameters and will be saved as numeric values. So, you will never be able to reconstruct what is originally fed from the output end. So, it's like us remembering faces. For example, when you see a person for the first time, you might be remembering some distinct facial features and the size of the person and those things. And in the next day when you recall it, you will not be reconstructing like a photograph, right? So what you will be doing is, you will be extracting those facial features and you will reconstruct an image through that latent representation that was there in your mind. So there is no guarantee that will be 100% similar to what you originally see. So that problem is always there in large language models as well. So it is not possible for us to recreate something that is originally fed into the model from the other end. That's because of the nature of this model, and it might seem like a limitation, but actually it's the reason why these models are so creative as well. So it is able to grasp every little aspect from all the training data and to reconstruct something based on those data, but not exactly the same data. Okay? So this leads to a problem. It's called hallucination, and factual inconsistency goes hand in hand. What it means is, so what is the original target of this model? It is to predict the next most probable word. That's it. It will not be checking whether it is factually consistent or whether factually correct. So it can produce very plausible sounding answers. When we read it, it seems really good, but we don't know whether it's true, because there is no inherent mechanism in this model to cross-check with some other references to confirm that it is factually valid. So that comes because of the nature of these models. So in some use cases like creative writing, fictions, poetry, in those cases this might be beneficial as well. So it might be able to grasp all the poetry, so all the text corpuses it has seen, and to produce something beautiful. It doesn't have to be factually consistent. But when it comes to some domains like medicine and legal aspects where the factual consistency is crucial, then we have a problem here. So we need ways and means to mitigate this hallucination problem, still to utilize the power of the large language models. And data bias occurs when the training data is biased. For example, in the earlier iterations of GPT 3.5, when we ask the model to fill in the blanks, blank is a teacher, it always goes for the pronoun she. The reason is, it has seen in the training data that most of the teachers were females. So that might not be true in some other parts of the world where there was no training data available for the model to train on that. So there might be data bias as well in the large language models. So we will be discussing about aligning the large language models to suit to our task. So we can discuss about the dual role of the large language models. It's like this. So when the OpenAI was developing GPT iteration 2, there were only few millions of parameters for these models. Okay? So when they feed the data and when they train the model and when they look at the output, it was nonsensical. So there were just some words, some parts of the word, but there was no structure to it, there was no meaning to it. And when we scaled up the parameters, when it comes to few hundred millions, it starts talking like a toddler. So there are words, but not a very good structure in it. But there is no specific intelligence emerging from the model. Then what they did was, they further scaled it up. Thanks to this transformer model architecture, they could expand. So when it comes to few billions of parameters, like in GPT-2 iterations, then it actually shows some hints of intelligence. So it could produce something that was not originally there in the training set, but it seems reasonable. And when it comes to GPT 3.5, like 175 billion parameters, it was like talking with another human. So like signs of intelligence was emerging from this. But the original mechanism how these large language models work did not change. It simply predicts the next word. But when we take the sequence of words, it gives us the illusion. Now, actually, this thing is thinking. This has intelligence, but it might be just an illusion. It might be the same thing that we are doing. We don't know. But the thing is, if it is useful, we can take something out of it. But what happens? They didn't stop there. They scaled it further. Then they scaled to a parameter of more than 1 trillion. So GPT-4 iterations have more than 1 trillion, 1.78 trillion parameters. Then it was like talking to superhuman. For example, in one demonstration in OpenAI, they asked the model a question like this. There was a hunter, and the hunter runs south 1 kilometer, turns left, and runs to the east 1 kilometer, turns left, runs towards the north 1 kilometer. The hunter ends at the original place he was. He sees a bear, he shoots the bear. What is the color of the bear? And in their demonstration, they claim that this original riddle was not there in their training dataset. So the answer was the bear was white. Why? If you start from the North Pole, you can come towards the south 1 kilometer, go to the east 1 kilometer, go to north 1 kilometer, and you will end up where you started, at the pole. And you see a bear, you kill it. So the bears usually in North Pole are polar bears, they must be white. So the most reasonable answer is white. So they claim that this riddle was not there in the training dataset, but somehow the model was able to reason and find this answer. So that's why I told you that there is a dual role in these LLMs, large language models. In one way, they can be thought as processing engines, intelligent reasoning engines. On the other hand, they are like information stores, like data stores. But the problem is this data store is not that reliable. It only contains a ghost image of the training data that we use to train. So there is no guarantee that the factual consistency is there. But we can harness the processing power, the other side of these models, for our own purposes. So the dual role here implies they can either be thinking machines, so reasoning machines, or they can be just databases. But this database is a latent representation. In other words, we cannot trust it that much. So our target is to mitigate this internal or implicit knowledge base, but we will be providing knowledge to the model. You use your thinking capacity to process it and give us a sensible outcome. So that is the philosophy that we utilize when we are using LLMs in our apps. So we want to suppress its implicit knowledge because we cannot trust it. So we will be providing knowledge, but we will be utilizing its processing power, its natural language processing capabilities to compile a good answer that is tailor-made to our problem at hand. So that's the philosophy. So how can we suppress its implicit knowledge and provide knowledge? So that's the next question that comes. So one way of doing it is called in-prompt aligning, which means we will be inserting all the necessary information in the prompt itself, and we will be asking the model to process it and give us the output. So when we specifically ask, do not use any information out of this context. This is the context that we are providing. Use this knowledge and process it and give us the answer. That is called in-prompt aligning. So that is one way of doing this thing. But there is a problem when we are utilizing this thing. So can you again remember that black box analog? It has in one side number of slots that we can input. So that actually is called the context window. So each of the large language models has a limited number of slots that you can insert. So for example, in GPT 3.5 it is 4K or 4000 tokens. In GPT 4 it's 128,000 tokens, so around 100,000 words. More than that you cannot include at one go. That's the limitation. And if the number of tokens that we will be inserting is too much, it takes too much computing power to process it, so it's very costly. So because of those things, in-prompt alignment is not always possible. But in some use case, it can be used. So when it cannot be used, for example, when the data that we want to feed is too big to fit into this context window, we will be utilizing a technique called retrieval augmented generation. We will discuss about that later. So that is what is meant by the philosophy of aligning large language models. So retrieval augmented generation works like this. This is just a simple diagram showing what it actually does. So imagine you have a set of your private data. It can be spreadsheets, PDF documents, books, whatever. So that is private to you. Private means that data was not there in the original data set that was used to train this large language model. So what we will be doing is we will be taking this set of data and we can split it into small chunks. And we can store those chunks in a specialized database. We call it a vector database after assigning a numeric value to each of these chunks. So what this numeric value represents is it captures the semantic or the meaning of that small chunk. So in other words, if you take two chunks and you look at how different the numeric values are, if they are similar, that means their original meaning or the essence is also similar. So likewise, we can take a large set of data and store it in a vector database like this. So that is the first step in retrieval augmented generation. Then what happens is then we ask a specific question that we want to answer using this data. So the first step is based on your question, there has to be a mechanism to select a few chunks out of this large set of data. So there is no need to feed this whole textbooks or this whole text corpus into the large language model. We will be selecting only a few relevant pieces or relevant chunks based on this vector database. And once we retrieve it, the process is like in-prompt align. Then what happens is we have the original question on the task, and then we have some pieces of data that are likely to contain the answer to that original question. And this set will be fed into the large language model to process and get the answer out of it. So we will be providing the context or providing the external knowledge to the large language model. We are not asking the large language model to use its own implicit knowledge to answer this question. So we are explicitly providing the knowledge and asking the large language model to utilize its processing power to come up with the answer. So that is the philosophy of, that's the mechanism of using retrieval augmented generation. So for this we need some components. So you might have understood that we need a way to access the large language model scope. It is given by the application programming interface or the API. So there is an OpenAI API, Anthropic API, Hugging Face API. There are many API providers that specifically do that task. They give us the way to access their model and get an answer. They actually charge for each token that is being generated through them. That is one thing. And we need a mechanism to break up our knowledge base into small chunks and to assign the numeric vector value. That is called vector embedding. So we need a mechanism to do this. So the other component we need is a vector embedding mechanism. Then we want to store these vectors in a particular database. So we need a vector database as well for this. And to coordinate between these all aspects, we need another layer. We call it an orchestrator. There are so many orchestrators there out. Some common popular ones are LangChain and Llama Index. So those things can combine these different components to form a complete application. So now we have different components that we have to utilize if we want to harness the full potential of the LLMs. So here, this is based on an analysis of 29,000 large language model based applications. So OpenAI seems to be the most prominent API provider among all of those apps. So 73% of the apps, LLM powered apps, uses OpenAI API for the large language model access. And 55% of them use some kind of orchestration tool like LangChain or Llama Index. And only 18% uses the vector databases. So most of them do not actually rely on vector database up to now, but it is coming up, and chatbots are on the rise. 31% of the all the applications seem to be chatbots. One reason is most of these chatbots don't need retrieval augmented generation or large text corpuses. They can be aligned, they can be tuned to assume a given role just by in-prompt techniques. So there is no need of using retrieval augmented generation in most of the chatbots. That might be the reason that vector stores are not being used, but the chatbots are on the rise. So you can see this top line is OpenAI. This is the OpenAI API usage, and this is the orchestration tool. The most common orchestration tool that was used was LangChain, and this is about the vector database. So Pinecone and Facebook AI similarity search of FICE was among the best vector databases that were used. Right. So all of these services are free to start with. So you can start your OpenAI developer platform account to get an API access for free. You can start for free, but it will be charging for every token that is generated through the API. That's one thing. And the vector databases that I discussed, Pinecone, and the orchestration models like LangChain and Llama Index, they are completely open source and free. So if you want to try them, it's actually possible. So if you go to the OpenAI developer platform just by googling it, there is a startup guide. You can choose your own, the language of preference. The most common language to deal with this large language models is usually Python, and it's also available in TypeScript, JavaScript based frameworks as well. So Madam talked about this automatic essay scoring system. So I will be just going through each of the components and how we manage to to compile all these things together to make a working model. So in automated essay scoring system, we used in-prompt alignment because there was not a huge set of data that to be used for this task. We just needed a clear rubric, a clear marking scheme for the tool to work. We don't have to go for books and retrieve data to use it. So therefore we went for in-prompt alignment in this particular application, and we knew that the answer or the feedback that is generated should be transparent. So it is not useful when you feed the answer if the application says, okay, this is 55%, so I will be giving you 70%. That's not enough. We want why. So even though the internal working of this large language model is so opaque, we cannot see it, but we can make it in a way that it talks with us in a transparent manner. So it will be telling us why this particular student got this mark. So that was our target. So what we did was we crafted a prompt like this. So this is called a prompt template. So we have a task. We first give the large language model a task. You are an examiner of pharmacology exam in medical school. Following are the questions and marking scheme for the exam, and we will be giving the context. We will be assigning the role, and after that we will be giving the marking rubric to the model. And there are three very clear tasks. First one is list down each point in the marking scheme, and if the student has mentioned the point in his answer, show the excerpt, or you have to extract what the student has written, and you have to show, okay, now for this first rubric in the marking scheme, this is the relevant answer that the student provides. And the second one is you have to evaluate the completeness of it and assign a mark based on the completeness. So we will be telling if it is complete 100%, this is the mark that it should be getting. So like this, and finally assign a total score to the student answer. Likewise, we are breaking this whole procedure into steps, and we are giving step-by-step instructions to the model. And when the model is run, these places will be filled. In other words, this is just a template. So based on each student's answer, a new prompt will be generated, and it will be evaluated through the large language model. So it will be, it provided, the output was like this. So for example, this is the first question, and these highlighted ones are what were there in the marking rubric, and then it shows student's answer and it evaluates. Now, based on these two, it seems like the student stated the answer correctly, or sometimes correct, though the term upregulation is replaced with supersentence. There is a small mistake there, which is a result of upregulation. So, likewise, it actually identifies the subtle differences between the original marking rubric and what is mentioned by the student. And it uses its processing power, not its implicit knowledge for doing this. Because we will be providing the knowledge to do it. It will be evaluating and it will be assigning the marks. So we can easily troubleshoot it. If we see some problem there, we can tweak the marking rubric for the second iteration. Likewise. So after doing that, we will be getting the final answer. So the final score that the student got, and incorrect points or the things that the student might have misunderstood in that particular question. So it seems like this student has not understood the mechanism of this drug correctly. Likewise. So at the end, it will be providing us a list of things that things that the student might have misunderstood, those incorrect points. So it will be very beneficial for the student as well, and it's good for us to evaluate the tool's accuracy as well. So this is a transparent tool which not only marks it but also provides us the reason for that. And this is the second application that I will be talking about. So our target was to create a drug information system for our students to use.
Yeah. Can I ask a quick question? Can you elaborate on the response? Large language models rely on the relational groups. Right?
Yeah.
So therefore, you have input an answer there,
yes,
and it has highlighted that part of it and said that is missing.
Yes.
But then, how do you translate that to a complete answer like the way you said?
Yeah.
Because you said the answer, final answer says this student has not explained this properly.
Yes.
So how do you translate to that? So from matching the words.
So you're asking me how we managed to get that out of this? Yeah, that's completely the prompt engineering. It's just simple task that is given. So I will be showing you the task. So that last part is coming just because of this sentence that was used in the application. So here you can see evaluate the correctness of the answer, and the scientific fact should be exactly correct. Based on the each point of marking scheme, assign the score to each point. Decide whether to give full marks or partial marks and mention your justification as well for each point and mention the marks awarded. Finally, assign the score, total score to the student's answer. Likewise, we are giving instruction in natural language, but we will be breaking them down into small segments. So, even though what the large language model actually doing is just predicting the next answer, next word, when we collect them and form a sentence, we see the illusion of intelligence emerging through it. So we do not know whether actually the large language models is thinking like humans and going to find whether the answer is there. We don't know that. But the final generation gives us the impression that it actually evaluates it correctly. So
it does give out complete
answers. Yes. So actually it provides this. So we first analyzed it whether it's correct or not. Then after some iterations, we saw that it's up to good standard. Then we distributed to the students and they gave feedback as well. So the important thing is, even though we don't know how it happens, so it's useful. So, and even though the inner working is opaque, the output can be evaluated in a transparent manner. So that's the beauty of this application. So the problem with the drug information system was, what we wanted to do is to create a platform for the student. Yes.
How long you have been training your model?
There was no model training per se. What we took was OpenAI's pre-trained models, GPT-4. We did some in-prompt alignment. So that means there was no training step that will actually turn those knobs. That is pre-trained. We are not touching the knobs. We are not doing a thing called fine-tuning here as well. What we are doing is in-prompt alignment or prompt engineering. Just through giving the prompt and giving the answer and formulating this complete prompt, we are asking the model to evaluate it. Right? So it's possible, if we want to go a step further, to collect a large amount of data like this and to do some fine tuning, not training the model from the beginning, but just to turn the knobs in a way that it will be more accurate. That will be a next step. But here it was not even done. This is just pure prompt engineering. Right? So in drug information system, what we wanted to do was to create a system that students can use to get information on drugs. The problem was whenever a student like Google's about a side effect of a drug. For example, if he asks whether the drug X has the side effect D, Google might say yes, because there might be at least one case report reporting that there was a side effect like that. But we don't know where Google is extracting this information and whether it's actually correct. So we want to base or ground the knowledge on reliable sources. So for that, one reliable source is US FDA of Food and Drug Administration. They have, for every drug, there is a drug label. It's around 5 to 10 pages long. So for all the drugs that are available, there is a FDA label. So there are more than 200,000 FDA labels out there. And we consider them as good information. So they are reliable because they base on most of the meta-analysis and aggregated results. Okay. So one way to get it is just to Google the drug's name and FDA, and you can download the FDA label and you can read through it to get an answer. But what if the student wants an answer for a question like, is there any interaction between this drug and this drug? And he wants to get it from based on FDA answers. So what he should do is he should get the first drug's FDA, second drug's FDA, read through both of them and see whether there is any likelihood of interaction. So that's what has to be happen. So what we did was we wanted to create a program that is grounded on this FDA datasets. So basically, whenever we ask a question from the program, it should go to the FDA dataset and extract the relevant document, read through it and formulate an answer and give it. That was our final target. So the workflow was, we wanted to minimize hallucination. We didn't want the model to use its internal memory or internal knowledge to answer this question. We want to use the FDA drug labels, and it should be able to do multi-hop reason in several steps, and it has to be grounded on FDA data. So we had to utilize retrieval augmented generation for this, because there was no way to fit the whole FDA drug data into the context window of the large language model. So we had to use retrieval augmented generation for this, and we integrated in the chatbots, and we will be discussing it later. So the workflow was like this. First we went to OpenFDA. OpenFDA contains publicly available data, drug data for all of us to use. So we downloaded more than 200,000 FDA labeled documents. It was more than 10 gigabytes when it came to the disk, right? So we want to have a mechanism to search through this set of data to retrieve what we want. So naturally what comes is vector embeddings. So then we wrote a small program that will be going through the text corpus and iteratively taking batch of 100 tokens, and it will be vectorizing them. Vectorizing means assigning a numeric value based on its semantic meaning. Then we were storing it in a cloud database. That cloud database is called Pinecone, which is available for all of us for free. And actually we were also surprised that we could use this free tier of this Pinecone to store more than 220,000 drug data in this database. So at the moment there are 220,145 drug data vectorized in this cloud database free of charge. So next thing is, now we have set up we use the orchestrator LangChain to code this thing, and we use Python language. We wrote it in Python notebooks. So the code is ready now. So what it does is, when you ask the question, for example, what is the dose of some drug, let's say paracetamol, what is the dose of paracetamol? So what it does is, it takes this question, what is the dose of paracetamol? Then it will be searching through the vector database in which chunks it's more likely to contain the answer to this one. It does this magic through vector searching. So we will not go into details, but it's possible to find the most relevant text chunk for a given query. So it will be extracting, for in this case we are extracting the top 10 chunks. So we will be extracting 10 pieces of information from this vast database that is likely to contain the answer to the original question. then we will be compiling a prompt, writing the original question in the top, then giving some instruction like find the answer to this question based on the following information that we will be giving, and that information is what we retrieve from the original database. So now we have like an essay, the question on top, some instruction, then some information that is likely to contain this answer. This essay will be provided to the large language model for processing, and it will be giving the output. So you don't have, for example, if we ask about 2 drugs, when we are extracting 10 pieces of information from the original vector database, it's likely to contain information about both of the drugs when we extract them. So what we are telling the large language models is, okay, I want to know the interaction between drug A and drug B. Is there any interaction? So what it is doing is, it is extracting interaction related information of the drug A, interaction related information from drug B, and producing an essay like prompt, and it will be feeding into the large language model. Large language model will be utilizing its processing power, not its implicit knowledge, to go through this essay and to formulate the answer. So that's the mechanism that's running. So producing it is not enough, we have to give access to that as well. So one way is to integrate into a web page and host it somewhere. That is possible. So another way that we thought would be much engaging was, we tried to integrate it to a chatbot, not a web-based chatbot, but to Facebook Messenger. So there are platforms like BotPress and Dialogflow where you can create a chatbot. In BotPress, you can create a bot and you can connect it through an API to your own servers. So what we did was, we hosted this in a Flask or Python server, and we connect the chatbot to that one, and it was integrated into Facebook. So what the student has to do is, he has to go to our page called FDA NK, we just named it like that, and they have to follow it, and what they have to do is just send a message through their messenger to that page. So the bot is waiting for any input, it will take the input, will process through our server and get the answer, will be directing it through the app itself. So it would look like this. So these are some answers that we got. So these are all drug related. What is the developer's action? What is the starting dose of losartan? So for these things, it will be extracting the data, processing it, and giving a detailed answer like this through their messenger app. So it's very accessible as well. So the other thing is, we can directly check whether this is true or not, because we have the original data set. Even though it's not giving the citation in here, because there was no way to get a hyperlink on this messenger platform, but on web platform we get the exact FDA label and where the information was taken from. So citation is there for us to recheck or cross-check whether information is correct or not. So the technologies, as I mentioned earlier, Pinecone was the vector database, LangChain was used for this orchestration, and BotPress for integrating into the bot, and the code was written in Python. That's the tech stack that we used here. And the last thing I'm going to show is another thing that we tried to do. We tried to create a personalized tutor in pharmacology. So the same principle. What we wanted to do is, students should be able to engage or talk to the tutor and ask something that he does not understand. For example, if the student is not, if he cannot understand about pharmacodynamics, so he can just go to the bot and ask it. But the important thing is, this bot is also based on the recommended pharmacology textbooks, Rang and Dale and the BNA. Those are the recommended textbooks for our curriculum. So it has already a vector database which is based on these 2 books and will only answer based on the facts on that. If the answer to the student's question is not there in this book, it will say, I don't know because I couldn't find the answer based on this. So that's one thing. And if it knows the answer, after a few iterations, it can give a personalized answer to the student. For example, if 2 students ask the same question and they carry out their conversation for some time, if one student cannot understand what the bot is telling, it will try to explain it in a simpler manner. So it will be a more personalized like bot, and we know it's grounded on data that we recommend, the recommended textbooks. So it would be able to function as a good tutor. So there is no direct way to measure the measure how it acts as a good tutor, but we can check its knowledge indirectly. So what we did in this study was, after compiling this model, we gave the tutor a set of MCQs based on the original textbooks, and we evaluated how it scores on this, whether it can actually extract the answer from the textbook. And you can see it scored 94% average marks. Out of 5 examinations, there were in 2 examinations it scored perfect 100% as well. So the technology works. We have the proof of concept. The challenges are when we are disseminating this technology. So there may be a lot of barriers when we do it. One is we have to learn how to connect all these pieces into one useful to compile this whole program using these different pieces, like the OpenAI and the vectorizing and orchestration. All these things has to be compiled to use this. And using OpenAI LLM and any LLM in that sense is costly. So for every token it generates, we have to pay. So there has to be a sustainable model to bear this cost. And we have to have infrastructure to host this as well. So thankfully we got the hosting space from the university. And so those are some of the challenges that we identified. And so this is just a landing page of our university's Sisuvat LPD and AC.lk, which was provided us with the help of Professor Roshan Ragel here. And we will be hosting the apps that we have created here, but the constraint is the cost, because we have to limit it, because the cost is going, there's no way to bear the cost at the moment if everyone starts using it. So because of that, we have to limit the usage, but that's one limitation that we have. So I think you got an idea of how to get the maximum out of these large language models using these technologies. So it's not just prompt engineering into ChatGPT that matters. So what we have to do is we have to harness the actual core large language models capacity using techniques like this, and it's very possible. So if you can come up with any use case that's relevant to you, most of the time it's possible to come up with a complete answer, or to compile these different parts and to compile the final software with the existing technology. So that's the message I basically want to give you. If you have any questions, I am to answer. And thanks a lot for the opportunity.
Can I ask you something? Actually,
Yeah.
it's quite nice and it's very basic. Actually, for the essay question evaluation tool, the input was the input as electronic answers.
Yes. Yes.
You
There
can't
was
have
no
a system
OCR.
for
No.
direct handwriting something
Yeah.
that would be fantastic.
Yes, that's possible actually. The OCR, so optical character recognition engines are there, but we didn't utilize them.
Yeah.
This is just for proof of concept that this works. So we got the high answer.
And also for the initial, that when you use the prediction model to identify the possible failure rate and the risk of failure rates, you use the data for the previous, say last semester, or
No, we use for 3 years backward data for 3 semesters for each year.
the students who took the same course.
Yes, the same was over the past 3 years, and we were like, it was not generative AI, it was machine learning models involving logistic regression, linear scaling. So what we were trying to do is whether the model can predict the final year exam mark using the previous 2 marks, and how accurate was it, and that was the thing that we did.
You are using previous examination as a
tool
tool
to
to
predict
predict
what will happen in the future.
how many 3 years, 4 years
3 years,
examination.
3 years examination, 3 semester per year.
3 semester per year.
Yes.
So the student confined to
That farm project was
that farm. So you have this limited amount of data.
Yes.
Okay, just to test.
that.
If the student get the new drug, for example, out of this,
Yes.
so just for curious, right? Is there any, say, some students are reading outside,
Yes.
right? Came up with something new drug inventions or something. So is that what will happen? Is that new thing, say something new?
Yes.
Is that it's confined to your only the examination data? Out of that, it's not giving any information.
No, the way we use these large language models is only the information that we will be giving it explicitly will be
examination.
used for the
Examination.
yes generation.
Examination.
Nothing will be used from the outside.
May I ask?
Yes.
You said that there's cost for each token that is
Yeah.
generated, right? Can you actually tell us like what's the actual cost for running this for 50 rupees? How much?
Yeah, it's like this. The cost is like $0.01 per 1,000 tokens. That's for the GPT 3.5 model. So it might be thrice or twice like that when you go for more accurate model like GPT 4. So 1,000.
Cent or $0.1 cent.
Yes, $1 per 1,000 tokens. So 1,000 tokens is around 750 words when it comes to English words. And that's for generation only. But to generate it, if you are reading more content, for each reading content, it also again costs. So that's so
Multiply.
yeah, so that accumulates.
Let's say
So when you give more context and ask to generate even a small sentence, it will be costly because the reading content is long.
So let's say practical purpose, if you want to have, let's say you have 2 credit hour course and you want to run it like every semester. For one semester, like if you want to run this, just one of the tools, how what will be the cost?
So to just give a ballpark idea, for the assessment tool,
Yeah.
to generate one assessment, it could cost around 5 to 10 cents like. So that would be the cost because we are using in-prompt. So there is not much of a content to be fed into the large language models. So that would be a ballpark figure. But the thing is, when we are going for retrieval augmented generation like things, depending on how much chunks that you are going to extract, it will depend.
So you can think of like what a run for something things, something that is useful thing. You see the feasibility. This is something I'm just looking at feasibilizing to do actually, instead of running and using so many numbers.
So you
We should be trying for continuous supply.
Yeah, that's why it was. If there is a sustainable model for this, we can continue.
I think there's a huge market potential for this as well.
Yes.
Among the educational institutes internationally, I think
Yeah.
you should really explore on that.
Yeah, that's aspect also good. Yeah.
I mean, what you have done is great.
Yeah, it's really good actually. It's very good.
So in fact, I'm in the commercial industry, I'm a lawyer for a tech company, and we do have this type of models. We are training them for customer service and different implementations, especially even for manuals, right? So we have products, we put a manual like that, people call, so we want to have an AI tool for that. So these are really useful for that kind of.
Something like just another course instructor just to give them and fine tune things, and it's really nice.
And we have had a great difficulty in stopping, right? You know where to tell the what to look, but we have had great difficulty in prompting where to stop. That's where the clustering comes in and all that. So, but I think you should have solved that problem as well. So it's a very good tool.
Example, now we see that I teach microbiology actually. So there is microscopy. So when we were students, so we come with color pencils, okay? And boys in my company used to steal from the girls. So we come and do it like that. But now what they do is that they will first come, take the picture with the microscope. Okay? First they will take all the pictures, then they will look up and see if the instructor has to say anything. And when you actually want to describe something, and when you try to show it in the microscope, they will look at it and sometimes they will just ask, okay, shall I show it in my screen? They will just show the screen and the students try to explain it back to us. So what I have noticed is that students feel more comfortable and they see it better on their screen than actually show it on the microscope. You see that you have huge potential with the current generation also. It is much sharper and nicer and more vivid in the microscope. But when you look at it, see that what is this? So actually, anybody speaking histology and pathology, I'm sure they have the same experience. Anything with images. Yes. They get it.
Okay, so thank you very much for engaging conversation. So the third presentation, Dr. Nalini Vedaki, she's working on AI-powered bot development, and she was formerly at Intel Corporation in USA for 12 years as a logic technology development engineer and a supply chain program manager. And she has a PhD from University of Kansas. So over to you, Nalini.
Thank you, Aki, for the introduction. Okay, thank you everybody. Good morning. So looks like we all are very blessed to have very educated people around, and it seems like I'm learning something every day. So I'm here to talk about how we can generate an AI chatbot using Google's platform called Dialogflow. So let me show you the agenda. So you know when I'm going to stop talking. So I'll introduce what is an chatbot. Then from there, I'll show you some websites where there are chatbots. So we can compare what they do and what are the limitations they have. And then I'll walk through the back end of Dialogflow. So that's where you configure your bot and you input all what you want to see in your bot. Then I'll support I saw Dr. Sikkim use the bot press, and I'll explain to you why I picked Dialogflow, because it's not the only one in the market, so but I made my choice. Then what are the potential users, and hopefully I can answer some questions. So what is an AI chatbot? Okay, before that, small explanation about the AI chatbots. So the most popular, the one in the popular kid in the town is ChatGPT. So like Dr. Subban explained the chart, it's about the root. And last night I was reviewing an article. It's a Stanford document they put out annually about artificial intelligence, but you have seen it already. So the ChatGPT is taking about 80% of the usage. So it's very highly interested in and very popular. So AI chatbots, it's a piece of software, I would say. It's powered by natural language processing platform. So it can understand human conversation, the language we speak, and it can understand the language and process a response that we can understand. So that's the beauty of an AI chatbot. So what are the benefits? So there is a huge long list. I listed out some of them. I'll read through. So not limited to predefined prompts. You feel like you're not talking to a machine but a human. Then it works from a script, so you have better control over it. And feedback loop and history collection. So if you see your robot is not functioning well, if it does any mistake, you can always go back and try to help out and see if it can do better and what you did. Then these are the three websites I want to go and explain to you. These robots, chatbots. Maybe I will keep saying robot and chatbot. So, this is the first example I want to show. Keep reducing the motion. I just wanted to show you some examples. But I have some screenshots, maybe I'll... Oh, there you go. Okay, so this is the Sri Lankan airline website, and this is where their chatbot lies. So when you open it up, you can see, so Ayana is trying to welcome you, And you can see it says, I'm a beta bot, I'm still learning and all that. You don't have to, I wouldn't put it there. So you say, you breathe, and you have some context, so some tabs. So they have share your feedback and live chat. So actually you can add more, because this is more like when you are meeting the purpose of having a chatbot, right? You're calling an agent. So let's see if we can, so the basic thing, okay, so let's see if we can greet. Say, let's say, hi, how are you? So that's a very basic intent, I would say. So it says the same thing. So you don't feel like you're talking to a human. You already feel, okay, you're going through a script, right? It's a machine. So it didn't greet you, so it gave you the same, but it will be something. So let me see what I can say. Can I book a flight? How can I book? Let's see, how can I book a flight? Right. So let's say what it says. So it says yes you can, and this option is available somewhere, so you go find your own path. So what if I do a spelling mistake? Can I do flat? Right? So let's see if it can still answer you. So it goes to fallback intent. It says sorry. Okay. So it's more like it's not proper. So there it has some limitations. Right? Then let me show you something else I was looking at. So it's Singapore Airlines, and that's their chatbot. So it is. So these are all things I tested last night. So this is, so it's called Chris. So it says, hi, I'm Chris, and this is what I do. And you have all these options. So you can easily pick where you want to go, flying or booking or package or frequently asked questions, right? So it's properly, I will say, configured, right? It can manual the user to their goal very nicely, very smoothly. Then let's try out something like what we did with Sri Lankan. So say, hi, how are. So it's very nice. So it says, well, thank you. So it's more like a human interaction. And let's see if we can say, how, to be fair, I'll ask the same question. How can I So you have a lot of information with some links where to go and all. So if I do same spelling mistake, let's see if we can understand it. Of course, right? So it worked last night, you don't have to do it. So it is still can recognize. So it's a nice robot, nicely configured. So I don't have a way of getting to the back end of this website. Therefore, I have my own website, something I created for a client of mine. So it's so this is the travel website for him, and this is the robot chatbot, and this is the icon for Dialogflow. And actually, you cannot configure the characteristics. You can change the color, but not the icon. But when you click it, this is how it looks. So I'll call it Mala. You can if you want to. So let's try some. Let's try to test. So say hi, how are you? Let's try to mimic what would a person user say. So I'm good. How can I help you today? So if I say, what are the best food items in Sri Lanka? So it says something. So if I rephrase it, what are the main dishes in Sri Lanka? So it can still tell you the same answer. So you can rephrase, you can come up with different words, still can tell you something, right? So this is more like this is an example, and I would say it's more like behaving as a human, or an AI-based chatbot. So let me show you the back end of it. So if you go to dialogflow.google.com, this is the interface of the Dialogflow console, right? So here you have all the options, and this is where you see what you have done. And here it's a small, so this is more like a playground, and this is where you test. So whatever you do here, you can come here and test it out, right? So you can create from here an agent is a bot, and all these items, the very important ones are introduced. So the intents, it's more like what the user wants. So then entities are the keywords. For example, if your chatbot is a appointment scheduler, so you say, okay, I need an appointment at 5 p.m. tomorrow. So 5 p.m. tomorrow are the key information in that intent. So those are the entities. So you have to you have to through there. So your chatbot will force you, the user, to input that information. So those are the entities. In the knowledge base, something like you can upload a document. So the bot will read through and answer the questions. So basically, you can use for frequently asked questions like, is your store is open? Is the professor into this? So those things, like very set information, you can edit. Then fulfillment is actually these three are the most important ones. And fulfillment, you can integrate it with your, if it is a calendar, so you can integrate it with your Google Calendar. For example, say Tilanka wants to have a personal setup so that her students can go and book times. So it will go to her Google Calendar. So things like that. So integrations, it's so integrations, these are all the integrations you can do. So you have your bot, and you can incorporate it with your, say, Twitter, Facebook, or your website, wherever you want to add. But until that point, until you get and do integrate it to a real platform, you don't have to pay. So you can play with your chatbot. You can do intense entities, and you can do knowledge bases and play with it. You don't have to pay anything. But when you are going to integrate it with anything in here, then it will start charging. So you have to have a bill account and pay. I'll get to the rates. And it's a little bit cheaper than what you explained, but I'll get to it. Then all these items, it's for your own tweaking. So the training, you can see the training, and the validation, it will tell you the probability, because when you have a document uploaded, you can see when the user asks a question, you can see the bot will try to read through the whole thing and pick the highest probable solution. So you can see sometimes it's find 9, sometimes find text, and find 9 will be picked. So you can see all that information in the validation, and there's history. So in the history, you can see if your button chatbot missed something, so you can always see there. So you can have you can tweak it in your database and knowledge base, so it won't miss it. So those are the information, and let me go back to. Do you have any question? I don't know how the forum goes, but if you have any question, please stop me and ask me, because I seems to have some technical difficulty as well. And while it is up, if I can ask something, okay.
Just a suggestion.
Yes, sir.
Now, in what you showed about tourism, I see a huge potential there for the as when we think about the country and economy. Because I mean, if you could open a portal like this to the potential tourists, they can design their tool like say, I don't see wildlife, and I don't see some history. So rather than asking, I mean, they take great trouble in finding an agent and going through, and they don't know whether it's reliable also. But this will give a good itinerary for the, I mean, you can visit Yala, Wilpat, when because
Yeah, in fact, that is the request of the
That client is,
services.
yeah,
His
he's
client
into
is
tourism.
looking for is going to open source it and have open platform. That's what.
Yep.
So it is open source. So it is
Dialogue?
open. Yeah.
Oh no, I'll show you some information. There is a good training period, and the charges are little less. Because Google is kind of generous company, so let's see. Anything else on this, so that I can go to the presentation?
May I ask one?
Yeah.
For the data set or that resources, for example, if you're thinking of that developing this for a like let's say assistant for a course or something, where you instructor like can we use the textbook as the like source input?
Yeah, so right now I'm trying to play with that too. So when you upload something, you have to clearly mention the question and the answers, at least for now. So sometimes it is having difficulty to read through and where to stop. So sometimes it's giving me the whole, sometimes two sentences or two paragraphs. So it's having some difficulties. So probably that's why I was asking you how long it took for you to train the model. So I think it takes some time. So more and more information, more and more training it gets, it will get better.
Yeah, it is something to do with clustering. So when you upload these documents, you have to cluster these documents and train point the bot to where it should look for, and also give keywords where to stop. So that is the kind of the magic behind it, and that's what he was also saying. So the whole magic is about where to start and where to stop, because the bot doesn't know. So as he said, it matches the keywords, right? The words. It will pick up from a word and match it to the vector it has, and then repeat it like that. So it just matches the words. It's not the bot doesn't think like the way we think, or candy, this is where I should go. It just matches the words. So it will get the best probability of the next matched word. So that's the magic in it. So you have to vectorize in such a way that you have to find a way to stop it. So but you can do it, but it takes a lot of effort.
And maybe I think we can see some potential for scheduling appointments. So in our context, one of the main things what we get is giving students appointments. So you have your mentors, you have your student groups, everything is coming and asking for an appointment. They have to either call you, either WhatsApp you, either message you, or else come to your office and get your dates. So if you can have kind of a bot like this, I mean, so that students can engage in conversation and then see what are the possible times for a particular lecturer for their scheduling appointment. So it saves a lot of time, I think. And also this does not require programming language, as I suppose. No. So that is also an additional advantage. So it's easy for us to get through. So it is
And
something.
yes, I think we can use upload many, because very recently there's a huge issue among the students that they are not reading this handbook for anything. Even rules regulation, and they are asking the same questions over and over again.
Right.
And when we upload those things and respective URLs to WordPress, they are going to answer based on that. That's one option we are trying also, but not it will happen next year. But it's quite good actually. Like even we miss sometimes some information that we can just check and get that information. But my question is, even with the previous one also, like let's say now students are asking questions at some situations that the available knowledge base is not enough. In that sense, is in this the other one we use, in that one there is an option to extract the information what are missing data, or based on the students questions what are missing in our knowledge base, and how we are going to develop that using like what else we want to, that we have to improve our chatbot lifetime. No, it shouldn't be something stable, it should be a dynamic situation. So in that sense, how we are going to improve that one, and who are going to be involving in that development process. So we thought of assigning couple of there are like options to assign tasks for different people who is going to feed the data, something like that. So I have that concern, like it should be improved with their question, because as the sir mentioned that even sometimes they read something else and they come up with a new question. So with that thing also it should be improved. Yeah.
Yeah, actually in the intents, so here you can generate an intent for all those fallbacks. So when people used to say it doesn't make any sense, what's the wrong answer, so things like that. So you can have your own intent for that one. Then you can see the responses. So in history, you can go so for all those inputs, so you can see the responses and see what they say, what was their mistake. It's for your own learning so that you can improve it. Okay. Next. I believe that's so I showed the UI and okay. So the okay, so here my explanation, my excuse is why I picked dialog flow. So there are some of the there are many AI bot creation platforms, but I picked Dialogflow because it's beginner friendly. So I'm a beginner learning, and then there is a free credit for new customers for 12 months. So I have been playing with multiple bots, and I'm still within that trial period. And then the request is about 5002. So for 1,000 you pay only $2, something like that. Then more than that, I like these two options because there's a large community support. There's a lot of people use this, and when you have a question, you can always go to a tech forum and get some information from there. You don't have to fill your head. Then extensive documentation if you want to learn by yourself. So Google, it's written everywhere. So everything is written, so you just have to take your time, read through the documents and understand. If you have a question, you can always go to the community because there's a lot of people using it. So those are the facts I looked at when I started learning to create chatbots using Dart. Then, so some of the potential applications I tried to list out, like like you said, it's in education. You can use that. Then you can have appointments for healthcare and personal assistance to do all this, put your reminders. And like my client, we have a travel and hospitality application. They need almost mainly customer service to answer frequent asked questions. If somebody has a question, don't drop my 7 24/7 support. You don't have to wait until the shop opens in the morning. So all that are potential applications. So any other question? I think that's the last slide. Yeah.
Just a few comments now. I'm a surgeon, and from medical point of view, and as broadly on looking from the country point of view, it's a great workshop. Simply to say, it's very timely now. Back in 1983, India picked up software. Now you know where they are. Now AI is coming up, and this is the right time we should pick it up as a country. If we have the right initiative, I think it can create marvels. So I think as academics here in universities, you can really drive this in the universities. And I saw a couple of months back, Mr. Vladimir Putin, Russian president, said he's going to teach AI in school. So they have taken it really up. So please take this into the university and wider education in the country. And then and you were talking about taking a grant. I think rather than taking a grant, this has huge market potentials. A couple of years back, I was in a medical education forum in Singapore, and so a lot of people marketing their educational tools, and your tool is much superior to those tools. I'm sure. Yeah. So consider really, please consider market potential, and you can sell this. So make it a commercial venture rather than looking for a grant. It will get huge money for you. I don't know whether it's, the government structures are very clumsy. Whether it's possible, it's up to you. And then again, I saw huge potential for language. For example, now, couple of months I was in Japan for a medical conference, and I saw Japanese are using much less English than 10 years back. They just pick the phone and show. Today we have. Okay, 10 years back when I was in Japan, they knew much more English, but they no English at all. Just speak to the phone and just show it to you in English. And so now the point is, our children eat up 30% of their valuable education time for education. They then eat the Tamil, Sinhalese learn Tamil, Tamil learns English, both learns English and French and Chinese and German and so on and so on. So why we are wasting 30% of our valuable time on a language? When AI is there, you just use your phone and the phone will speak for you. So I think as a country, I mean, you are the people who can drive this really through, because don't expect the politicians to do this. They are clueless about this. But if you people are going to say that, it's great. And again, from my point of view as a medical staff, the human manpower situation in medical field is really critical. A lot of people are going. A lot of our small hospitals are going to be manned by really immature people. Excuse me for that saying that. I'm not immature, but junior people rather understaffed. So how if a pancreatist lands in district hospital Ududumbar in the night, how is the management? How they are going to save the patient till he goes to Kandy? And ambulance is not there. So how the doctor in base hospital Ududumbar know how they are going to manage pancreatitis in the night? So it's just, you can use this, you can have an app like that, for surgery, for emergency care. It's really going to create marvels. And again, for the country, the administrative structure is really clumsy. The officers are really clumsy. I think the answer is here. We don't have to pay a huge chunk of our money for the huge stuff we are maintaining. Just use AI. People will be happy. Country will be more efficient. And so it's great. Please take it up.
Thank you for all the engaging conversations and suggestions and everything. So I take this opportunity to thank my team, actually, Dr. Sukul Manachunga and Dr. Nalini Veraki, for coming all this way and sharing our experiences and making this event successful. So I hope everybody got something out of this, which will be beneficial for your career. And you will see a lot of applications coming through developing and support each other. And another thing which I would like to suggest is that we need to have a kind of a resource pool for tool development, as we discussed so far. So we need to have software engineers and thinkers and people. And even though you have an idea that I need to develop this type of thing, there should be a kind of a resource pool to go ahead. This is something we can think of and discuss in the forum and go ahead. Thank you.
So, yeah, to conclude the session, I would like to thank our resource panel, Professor Prilanka Siniratna, which always been with us, and Dr. Sukul Manatunga and Dr. Nalini Veraki. So I think I was texting one of my friends like this. For me, this was the best IFA session so far. So I think you all did really well, and everybody was engaged, and we almost forgot Gilbert as well. Yeah, I saw the best engagement today as well. And madam, I think the last suggestion you gave, I think we should make an expert pool, just a little document with names, contacts, and what are the expertise you could bring in. If somebody wants to make a bot, who should we consult, something like that. So we will take a note. I think we take a note on that. And also, I would thank the participants first for participation and also for the questions, comments, and engaging discussion. It was very live. And finally, Ragil sir, Pramila madam, Chintini, and Roshani, the team, I would thank them as well. So be with us. We will be updating you on the next event as well.
Have a nice day.
We have